The first question is to find, now, as usual, please pause and have a go before you watch the solution. This question is essentially a C1 question, okay? If we say that y is equal to c squared over x, then dy by dx, I'm just going to rewrite that as c squared times x to the minus 1. So the usual rule for the derivative is multiply by the power and take 1 away from the power. So that is equal to minus c squared x to the minus 2, which is equal to minus c squared over x squared. Okay, so I've just rearranged this equation to make y the subject, and I found dy by dx. And the reason why I've done that is because dy by dx gives me the gradient of the tangent. Okay, now, like in C1, at the point CT, so that's your x coordinate. So now, if I substitute x is equal to CT into dy by dx, I get the gradient. So the gradient m is equal to minus c squared all over c squared t squared, because I've substituted x to be CT. And that is equal to minus 1 over t squared. So now I have my gradient. So let me remind you that the equation, now remember the word tangent is simply a straight line. And the equation of a straight line is y minus y1 is equal to mx minus x1. We are given, I'll highlight this again, that's your x1, that's your y1. Okay, and we've already found the gradient, and we just need to show that you get that. So let's just put it in. So y minus y1, y minus y1, which is c over t, is equal to the gradient, which is minus 1 over t squared, x minus ct. I multiply both sides by t squared, I get t squared y minus ct is equal to minus x plus ct. And therefore, x plus t squared y is equal to 2ct as required. Now, part B says that the point P lies on H. The tangent to H at P cuts the axis at the point X with coordinates 2a 0, where a is a constant. Use the answer to part A to show that P has coordinates. So this is how we do this part. So I know that when X is equal to 2a, Y must equal to 0. Okay? So if I substitute that in to this equation, because X tangent cuts the x-axis at the point X. So the point X lies on the tangent. We have the equation of the tangent from part A. So they're telling us to use the answer to part A to show that P. So let's just find the value of T first. So we substitute that in, we can say that 2a plus 0, because t squared times y is 0, has to equal to 2c t. Therefore, t is equal to a over c. We know that. Okay. Now, we know that any point, the point P has coordinates ct, comma, c over t. That's right, isn't it? But now we can substitute in t is equal to a over c. So ct is c times a over c, and that gives us a. I don't really need to write that out, do I? C times a over c is just a, comma, c over t. This is t. C over that gives us c squared over a. Okay, let me do that in the same color so you don't get confused. So where did I get that? I substituted t into the coordinate for p. Yeah. A and b.